Got it. Now I can make it a little bigger. All right. We are moving into biconditional statements. You know that the N does not belong in here. That says bin conditional, that N does not belong in there. So hopefully you remember that conditional statements are if-thens. Biconditional statements can be created when a conditional and its converse are both true. So remember, a converse, think of the shoes, put them on your wrong feet. When we flip-flop the hypothesis and conclusion, if that one's also true, you can create what's called a biconditional. So the way we're going to make it is if you have an if P then Q, and when you switch the order, if Q then P, if both of those are true, then we're going to create what's called a biconditional. And the arrow notation looks like this. It's a double-headed arrow. And what that double-headed arrow means is it's P if and only if Q. So this phrase, if and only if, comes up quite often when you're doing proofs and definitions. So math people, being the lazy people that they are, they like to abbreviate if and only if. And the way that's abbreviated, if stands for if and only if. Okay?
Sure, okay. that makes total sense.
Total sense. I can't help what math people did in the past.
People are totally smart.
They are. See, we were doing little shortcuts before texting even came along.
Yeah, and
that's all created by math people. Yes.
So would it be like if you have 12 inches, then you have 1 foot?
So then if you have a foot, then you have 12 inches. Perfect. So we could say 12 inches if and only if 1 foot. Okay. And it doesn't matter, the P could come first or the Q could come first. So we could also say Q if P. So you can't get the order wrong on a biconditional. You just have to have if and only if in the middle. I prefer the shortcut. So it says write a conditional and its converse from the given biconditional. So here we go. An angle is acute if and only if its measure is between 0 and 90 degrees. So give me an if then from this. So I want you to throw away the if and only if and put in an if and a then. Can you tell me one of them? Yes.
If an angle is acute, then its measure is between 0 and 90 degrees.
Perfect. You throw away this. You put an if at the beginning. If an angle is acute, then its measure is between 0 and 90 degrees. That's my B, yeah. Okay. Now it's asking us to write the converse, which we practiced the other day. Converse switches the hypothesis and conclusion. So what's that sentence going to be?
Wait, if you just change it?
Yep, you changed the order. Go ahead, Drake.
If an angle is measured between 0 and 90 degrees, it is acute.
Perfect. I love the way he put, instead of just saying if its measure is between, he said if an angle's measure is between. So we really know what's happening at the beginning. But he is making this part the if. So if an angle's measure is between 0 and 90, then it is acute. Okay. Pretty easy so far. Now it's asking you to write the converse and write a biconditional. So this time they're giving us the original conditional. If points are on the same line, then they are collinear. Let's write the converse. The converse is an if-then. So, what do we got here? Yes, Nate?
If the points are collinear, then the points are on the same line.
Okay, perfect. So again, he's replacing they with what we're actually talking about. So he said if the points are collinear, then they are on the same line. Okay, now we're going to write the biconditional. The biconditional doesn't start with if. It sticks that if and only if in between the two ideas. And it doesn't matter which idea comes first. It could be the P information or it could be the Q information. So there's going to be two correct ways to write the biconditional. We're only going to write one. So the way you're going to do that is, it's pretty simple. You're going to go to either one of these. It doesn't matter which one. You're going to throw away the if, throw away the then, and put the if and only if in the middle. And it should make sense. Go ahead.
The points are on the same line, if and only they are collinear.
Perfect. So the points are on the same line. We didn't have to change anything. Points are on the same line. If and only if they are collinear. The other correct way would have been to take the converse and do the same thing. Throw away the if and say the points are collinear if and only if they are on the same line. So throw away the if, throw away the then, stick in the if and only if. Are you good on that?
Mm-hmm.
That's pretty simple, I think. Now the truth value of a biconditional. So we're going to decide if a biconditional is true or false. Okay, it's true only if both the conditional and its converse are true. People tend to get lazy. They'll check it the one way and call it good. You got to flip it and check it again. So I'm going to make you do the long work here, but in the homework you won't have to write it all out. So check. So first, what you would want to do is write the first if then. So we're going to throw away the if and only if. If y equals -5, then y squared would equal 25. Is that true or false? If y is a -5, will y squared equal 25? That's true. Now we're going to switch the hypothesis and conclusion. If y squared equals 25, then y equals -5. Is that true or false?
False.
You're telling me false, which means you can then give me a counterexample. What's the counterexample to this? Because you want the first part to be true. So if your y is a 5, is 5 squared equal to 25? Yep. But then over here, was your value equal to -5? No. So because the converse is false, is this biconditional true or false?
No.
False. The only time it's true is if both of them are true. So you have to check both ways. Are we good on that? And I'm saying on homework, you won't have to write these out. You can just do it in your head, check it both ways, and you'll be good. Okay. Oh, definitions, my favorite. Not. Okay. Definitions can always be written as biconditionals. You can start with the definition and say it is the word, or you can start with the word and say it is the definition. So, but we're going to take it one step farther here in geometry. You are going to be, here's an example. Oh, slow down. Let me give you a definition of a polygon. Is a closed plane figure formed by 3 or more line segments, each intersecting exactly 2 other segments only at their endpoints. Totally obnoxious. Why do I have that in there? But anyway, I wasn't supposed to give you that. But anyway, here's some examples of polygons. Okay, these are some examples that are not polygons. Okay, wait for you to get all drawn.
I hate the one that isn't fully closed.
So what I want you to be able to do here is look at these examples of things that are not polygons and see where that shows up in the definition. So what is this picture? Where does that come into play in the definition? A closed. So the closed idea is coming from this one. What about this cube here? Plane. Remember, plane means flat, two-dimensional. So this one's plane. And then what about this one? Yeah, that whole idea of formed by 3 or more line segments, each intersecting exactly 2 other segments only at their endpoints. So that took a lot for this picture here. But yes, the segments only join at the endpoints. They don't cross anywhere else. So you're going to be writing your own here in a minute. But now, because you've got this definition here already given to you, could you write it as a biconditional? And just remember, biconditional means you want that if and only if. So what can we do with this whole thing? Yes.
A figure is a polygon if and only if.
Okay, stop. That was perfect. He started it out perfect, so I just want to get that started. A figure is a polygon. So it's the word that's your beginning. And then what did you say after that? A figure is a polygon if and only if.
It is a closed plane figure formed by 3 and then the definition.
Yeah, and then the whole thing. I'm not going to make us write all that out again. So we're just going to start it so we know. If and only if it is a closed plane figure dot, dot, dot from above. So we had to add that little bit of wording at the beginning. A figure is a polygon if and only if, and then added it is a closed blah, blah, blah. So guess still getting a complete sentence there, but the if and only if in the middle. Okay, try another one. This one will write the whole thing out. Quadrilateral, a 4-sided polygon. Can you turn that definition into a biconditional? Yes.
A figure is a quadrilateral if and only if.
Yep. A figure is a quadrilateral if and only if it is a 4-sided polygon. Okay, now let's see if you can come up with your own definition in a biconditional phrase for a rectapentagon. You seen rectapentagons before?
No.
No. Well, here they are. These are rectapentagons. These are not rectapentagons. Okay, here's your first rectapentagon. Okay, so get all those down. So before we try to form the definition, we kind of want to get the characteristics of what a rectapentagon has. And we'll just start listing what they have to have. Ethan, what do you think is one of the characteristics?
2 right angles.
2 right angles. But so do these two have 2 right angles, and they're
on the
not.
same line. They share like a similar line.
Yeah, does anybody know how we can describe these two next to each other versus these two not next? Well, these two are next to each other. 2 from one to the next. Do you know what that is? Consecutive. Those are consecutive vertices. So 2 consecutive right angles. What else does a rectapentagon have to have? Yes. 5 segments. 5 sides. Is that it? Yeah. What do we call those things that only intersect at their endpoints? Polygon. That has all the characteristics of a polygon. Perfect. Is there anything else we would need to put in our definition? I think we got everything. We got the 5 sides. We got the 2 consecutive right angles, and it has to be a polygon. So can you take these 3 ideas and blend them into a nice if and only if definition? I'll start it out. A figure is a rectapentagon if and only if. Now it's just making it flow nicely. Kind of English writing people do we have out there? Yes, go ahead.
A figure is a rectapentagon if and only if it is a polygon with 5 sides and 2 consecutive right angles.
I'm going to even do a little bit better. It is a 5-sided polygon. Let me cut out a couple of words. With 2 consecutive right angles. Oops. Nice job. I kind of went off the screen there. All right. That ends that section. Wasn't too bad. Ooh, we're almost on page, we're going to go past page 100 today, I think. Page 99. I guess I'll write. Everybody have this so I can turn the paper? I kind of ran out of room. Page 99. 10, 12, 14. Oh, 16, 17. 18 through 26 even. 27. 30 to 34. I'm going to stop there. I think that's enough for you. And looks like you got a half hour to work on it. Tomorrow we've got a quiz review, which puts a quiz on Monday. Yes,
Can I use it?
absolutely. Say it again.
I forgot the book again.
Okay, go. You stuck already? What do you got? Yep. Okay. I'm all good here? Oh, I gotta stop that recording. Give me 1 second here.